In this problem, we're going to be finding the equation of the line tangent to the graph of f at the given point. Okay, so in this problem, we have an inverse sine function, and inside that inverse sine function, we have another function, which is x over 4. Okay, so whenever you're wanting to take the derivative of an inverse sine function, so d over dx of sine inverse, and that inverse sine function has a function inside of it, we'll call that function u of x. Okay, here's how you do that. You multiply the fraction that you get by the derivative of the inside. So we'll just put that on top. So u prime of x divided by, and then the square root of 1 minus u of x squared. Okay, so obviously u of x for us is x over 4. Okay, so the derivative d over dx of x over 4 is, of course, just 1/4. Okay, the x goes away. All right, so we want to find f prime so that we can get on our way to finding that tangent line. So f prime of x, so we put the derivative of the u of x, derivative of the inside, on top, so that's 1 over 4. We already found that. And then on bottom, we had the square root of 1 minus the function squared. The function's x over 4, so x over 4 squared. Okay, now we can clean that up a little bit, probably advised. It doesn't necessarily say that we have to, so you could just stop here, because what we're going to do is plug in that x value too and get an answer. But if you wanted to clean it up, it's good practice anyways. Here's how you would do it. Let's leave that 1/4 on top for now. Okay, and on the inside of this square root, I'm going to distribute the square. So it'd be x squared over 4, or 16, excuse me. Okay, so I want to combine these two things right here, the 1 and this fraction. So I'm going to write the 1, instead of a 1, I'm going to write it as 16 over 16. Now that's still 1, right? But now we can combine these two fractions on the inside. Okay, so I get 1 over 4 divided by the square root. See, the tops are 16 and a minus x squared, and the bottom is a 16. Okay, now since I've done that, remember you can take the square roots of different parts of the fraction if possible. So this square root right here has a nice answer, so we can go ahead and square root it and bring it out. Remember, it'll still be a fraction, so when we bring it out, it'll be 1 over, and the square root of 16 will be 4. Okay, so here's my 1 over 4 on top. We'll take care of that in a second. A square root the 16 that's on bottom, bring it out, it becomes a 1 over 4 because the square root of 16 is 4. And then square root of 16 minus x squared. Okay, one more step to get this thing clean. I am going to bring this 1/4 out to the front. Okay, or you just bring the 4 down and leave a 1 up top. Okay, so it would be 1 over, here's the 4, that's 1 over 4 from here. I'm just bringing the 4 down. Here's the 1/4 that was already there. Okay, and here's the square root. 16 minus x squared. Okay, the 4 and the 1/4 will cancel each other out, so we get a nice cleaned up version of this derivative, which is 1 over 16 minus x squared. Okay, so that is going to be the derivative that we're going to use. That's f prime of x. Okay, so it didn't say find the derivative only, it said find the graph, or find the equation of the line tangent. Okay, so in order to do that, we need 3 things. We need an x and a y, which we're given. This is x, this is y. Okay, so we have 2 and power over 6. We also need a slope. Okay, so m, which is your slope, we're going to find that by plugging in 2 into f prime. So it'll be f prime of 2. Okay, so that will be equal to 1 over the square root of 16 minus 2 squared. Okay, and that will be 1 over the square root of 12. Okay, and if you want to clean that up, which you might want to at some point in the problem, if you want to clean that up, you can square root of 4 out of this because this is 4 times 3, so the 4 could come out, and it would be 1 over 2 square roots of 3. That would be the cleaned up version of 1 over the square root of 12. All right, now we have y minus y1 equals m times x minus x1. We're going to put the 2 here, pi over 6 here, and the slope here. So y minus pi over 6 is equal to 1 over 2 square roots of 3 times x minus 2. Okay, now if we clean that up, that would be y minus pi over 6 is equal to, let's distribute this. It's going to be x over 2 square roots of 3. That's this one. And then it'll be minus, not equals, sorry, minus, okay, 2 over 2 square roots of 3. Okay, I'll reduce these on the next step, and I'm also going to move this pi over 6 over. We have to add it to both sides. So our final answer will be y is equal to x over 2 square roots of 3 minus 1 over square root of 3, and then plus pi over 6. And that is our line tangent at the point given. And that's it.